Welcome. In this video, I want to fold an equilateral triangle. More specifically, I want to start with a square and fold it into an equilateral triangle. And I'm going to do this in three different ways. And each of the three ways uses a property of the equilateral triangle. Actually, it uses a property of half of the equilateral triangle. So I'm going to use this circle drawing template to just give me perpendicular. I want to cut this equilateral triangle in half. Now there's lots of ways you can cut triangles in half, but it turns out with an equilateral triangle, they're all pretty much the same. That is, if I were to draw the angle bisector, it is also the median, that is, it bisects this edge. It's also an altitude, so this is a right angle. This isn't true for all triangles, but for an equilateral triangle, the perpendicular bisector of the side, the median, the altitude, the angle bisector are all the same thing. So the equilateral triangle had all of its sides equilateral, all of them the same length. So this one here that's been cut in half, if I call this length 1 and this length 1, it means the whole side has to be length 2. And if I now look at just half of it and say, let me use the Pythagorean theorem to figure out what this other side is. 1 squared plus this squared has to equal 2 squared. So that's got to be the square root of 3. The angles, on the other hand, started off all as 60 degrees, or pi over 3 for you radian fans. And this one right here, the 60 has been cut in half, so it is 30 degrees, or pi over 6 for you radian fans. A 30, 60, 90 triangle has side lengths in the ratio of 1 to 2 to the square root of 3, where the hypotenuse of 2 is twice as long as the shortest side. Okay, and that's what I'm going to be producing. Okay, so here we go. Let's make an equilateral triangle. I'm going to start by my piece of paper. For whatever reason, I'll fold it with the color side down. It doesn't really matter for this demonstration, but it's the way I'm doing it. Cut it in half. So you fold corner to corner or edge to edge, however you want to think of that. Hamburger fold or hot dog fold for a square. Now I'm going to fold through this corner so that that corner ends up on the edge that I just made, on the fold that I just made. Okay, so put my pen down there. I'm going to fold through the corner. It's going to go through the corner, and then this corner is going to end up on that edge. Okay. Now, where in this process do I have a 30, 60, 90 triangle? How do I know that I just made the right fold? Well, where is it? Actually, it's right here. If I were to, from this point, drop a perpendicular down to here, that thing that I just dropped is exactly half the length of the square. And yet this diagonal right here was the side length of the square over there. So it's still the side length of the square here. And what I have is a hypotenuse of 2 and a short side of 1. So there is a 30, 60, 90 triangle. So this is 30 degrees, which means the rest of this is 60, which means that's 30. Anyway, I can then do this on the other side as well. Making sure that point lines up with that crease that I fold. Maybe it's kind of hard to see that crease. I'll dot it in there, but that's the halfway line. So that corner is lining right up on that line. Fold goes right through that corner, and I've just made another 60-degree angle right there. So there is an equilateral triangle. The side length of the square is the side length of the equilateral triangle. Okay, so there's method number 1. Now I'm going to do number 2. I'm going to start with my square. Again, I'm going to fold so that I cut it in half to a hamburger fold or a hot dog fold. Now I'm going to cut half in half. So I'm going to fold the edge to that middle line that I just created. Okay. Now I'm going to fold through the point here on the top so that this corner falls on that fold, the second fold. So here we go. Fold through the top point right in the middle so that this corner falls on that fold. Notice right here is a 30, 60, 90 triangle. How do I know that? I know that because this short side right here is actually half of the, right? This was half of the side of the square, and then I cut that in half. But the diagonal is half of the square. So this is a quarter, this is a half, so this is the ratio of 1 to 2. 1 to 2, and there's a right angle right here, so that's a 30, 60, 90 triangle, with that being 60, and that's 60, and that's 60. I've got my 60-degree angle. I can then take this and fold it right along there. Bring that right into there. These two should be the same distance from the bottom, and you can fold along that edge. I always find this one of the trickiest folds to do, to fold the line through two given points. It just is annoying to me, but it's possible to do. Maybe if I do it this way, it'll be easier. And then fold it back over. But there's my equilateral triangle. I'll leave it like that. This edge across the bottom here is the same length as the edge of the square to start with. In fact, you can see the edge of the square down here. So this one and the first one we did produced equilateral triangles exactly the same size. The side length is the edge of the square that we started with. But this one has the triangle with the point of the triangle touching one of the original edges, where the first fold pattern has the bottom of the triangle, one of the edges, right? So this has edge on the edge of the square, this has a point on the edge of the square. Now, one more way of doing this, and this actually will produce the largest possible equilateral triangle you can fit in this square. Right? So again, I'm going to fold it in half. If you've been doing Hamburg folds on all the other ones, let's do a hot dog fold this time. For a square, it doesn't matter, right? Okay, that's folded in half. Now, I'm going to fold through this corner so that this corner ends up on that fold. This is a little tricky here. Let's see if I want to get that corner right there. This is actually a really fun fold, I think. That the fact that what I'm actually going to do is fold a 15-degree angle. I missed the corner a little bit, but the idea is that you go through the corner. Where's my 30, 60, 90 triangle now? Actually, it's right here. And then across the bottom. Across the bottom is one half of the original side length. This hypotenuse is the original side length. And so with a right angle right there, I've got a 30, 60, 90 triangle. And so this is 60 degrees, which means when I open this back up again, that was 30 degrees cut in half. So that's a 15-degree angle, and that's a 15-degree angle. Okay. Now I actually have two ways to proceed from here. The equilateral triangle has three sides, and it's like, which one am I going to do next? One thing I can do is just repeat the process going over this way. So I'm going to fold it in half here. And then I'm going to fold this corner up to touch. And again, I got to get that right through the corner. It's always a little tricky. And at the same time, I got to get this corner on that line. I feel like I'm trying to do two things at the same time. So I had 90. I take off the 15 there and the 15 there, and I've got a 60-degree angle right there. These 2 points can now be used to fold this down. And you've got an equilateral triangle. This equilateral triangle, it turns out, is the absolute largest you could possibly get inside of the square. Notice, I'll compare it with one of the other ones. The side length is a little bit bigger, right? It's a little bit bigger right there. And so it has the corner of the equilateral triangle right down here at the corner of the square. So as I said, I have two different ways of getting that one. So let me do that one more time. Okay, so I have that one done. Now I'm going to, instead of folding this edge over here, I'm going to fold that one. And I'm going to fold this one, noticing, and when I did it before, it's exactly symmetric about the line down the middle, the diagonal down the middle. So if I were to fold that diagonal, I can now take this corner and bring it back to the diagonal, right? But I want to do it in just the right spot that the fold passes through this corner right here. And that would be a 45-degree angle there, and it's what I need. And there we go. Then it's a matter of folding through this point and that point to get that last edge. And again, I really am not a fan of this folding through two given points. I like doing point to point. That's a good fold. And just for make things look better, let's fold that around for a nice equilateral triangle. Okay. So 3 different ways to fold an equilateral triangle out of a square.